In this tutorial, we'll go through the function list item by item. So if we bring up functions FNC, we'll find that we have none defined. We will add one. Use the add command, add1, enter. And then we go to the function itself, FNC1. If we bring the highlight down with a down arrow to the function type, and we use the large plus key on the key number pad of your computer keyboard, and we can use that to increment the function list one at a time. Pressing it once will bring us up to function type number 1. And you'll find in any function in the system, it will ask you for specific information. Generally, from here, from the pitch offset, if there is one, up is information that you need to deliver to the system in order to make the function valid. Anything below here where it says bottom note limit, top note limit, etc., these are optional things that you don't need to define unless you need to for the particular type of function you are going to create. So what we have here is function type 1, which is a divisional coupler. This satisfies the requirements for an intramanual coupler or an intermanual coupler. A intermanual coupler is from like solo to great. An intramanual coupler is like solo to solo. So if we come over here to couple from keyboard, we can enter the keyboard by its number, its element number, for whatever keyboard you want to couple from. And you move down here and you add whatever keyboard you want to couple to, and then you can change the offset to whatever pitch offset you want, from 32-foot pitch all the way up to a quarter-foot pitch. So, for example, if we wanted to make a solo to great coupler, we would put in the keyboard number for the first couple from keyboard, in other words the solo, which would be in this case it would be keyboard number 3. And we would arrow down or cursor down to highlight the couple 2, which would be keyboard 2 or the great. And then we couple down here and we have an 8-foot if we want to leave it at that, or we can change the offset pitch to any other pitch that we wanted. For example, a 4-foot would be an offset of plus 12. So now you can see that the computer has created its own name up here, a 4-foot solo to great foot coupler, which means anything or any stop that is activated on the solo, the couple from keyboard division, will now play on the couple to keyboard division, the great. Now if we cursor back up to the function type and press the plus key, we will go to function type 2, which is a rank to rank coupler. Here it's asking for information that you need to furnish from couple from what rank and couple to what rank. So if we wanted to couple from rank number 1, the flute, we wanted to couple that to rank number 2, the piano, at 8-foot pitch, we could do so. So we're just basically filling in the information that the system wants from previously defined rank and keyboard information that we've already set up in the system. So in this case, when you activated this particular function, it would play both the flute rank and the piano rank at 8-foot pitch. Now we could, if we wanted, optionally, we could specify a bottom note limit and a top note limit. The third type of function is one we've already shown in our introduction to the editor when we built our single one-rank organ, and that is couple from the keyboard, from the great, and we created a flute rank, and then we add a pitch offset, and we could make that minus 12, which would be 16 foot, a 0 offset, which would be 8, a plus 12, which would be 4 foot, or we could use the plus key on our number pad and increment them offset by offset and create any pitch that we wanted. And even non-specific pitches, non-standard pitches, if you want an offset of plus 20 notes, which would be 1/2 step higher than a 2 2/3, you can have it. It just depends on what you want to do, and you can experiment to your heart's content by building a couple of functions and going through and just changing the information that is asked for in the function definition itself, and that's basically the way you learn how to program this system. It's just by doing it and making some notes and so on and so forth. Now, if you get to something here that you have tried and you say, oh boy, I wish I could remember how to do that, what you can do is you can come up here to the file, come down, and if you attach a printer to your computer relay, or if you're running this relay on a remote system that has a printer already attached to it as a demonstration system, then you can click on print, and if you have a standard Windows printer and a printer driver installed on your system, then you can make a print hard copy of any of these functions that we're doing. So if you want to take the time and install a dot matrix or a laser printer on your organ computer system, just plug it in and then furnish the system driver for that printer to install that on the computer, and then you can print out any of these sample definitions that you create on your organ, or you can take your own definition list and or definition file and print it out item by item. So continuing on with the system, going to function type number 4, which is normal trap output. This is asking you for a keyboard number, great for example, and then a unit number. Now from the unit list you would type in the number of the unit that you wanted to have as the trap unit. So if you move the cursor down to the unit number and you already have them defined, you can press the plus key and that will start incrementing them from unit number 1, which would be the triangle, tambourine, castanets, etc. If we go to function type number 5, this is a direct unit output. And here, for example, this if this was tied to a stop, then this would turn on, for example, a trem. So if we scrolled through our unit list, number 1 would be triangle, no. 2 tambourine, 3 castanet, no. 4 would be string trem. So now when you tied this to a stop, turned that stop on, then it would turn on directly the string trem output for as long as the stop was turned on. Function type number 6 is a division unison off. And this is a reverse coupler. Normally the system has a unison coupler in place and it is always on. So if you were to specify the keyboard, whenever you activated this stop, it would turn the unison coupler off. Keyboard sustain is function type number 7 and asks for a keyboard. So if you wanted to have a keyboard sustain on the solo, or if you wanted to have it on the great, then you could just build this particular function, just fill in the blank that it needed, which is the keyboard or keyboard division that you wanted this particular function to affect, and tie it to a stop and or a momentary button, and then you would have a sustain. Function type 8 is a keyboard legato. Keyboard legato, keyboard sustain, and keyboard sostenuto are all in what we consider the sostenuto family. A keyboard sustain is additive. In other words, if you start with C, E, G and then keep adding more notes, they just continue to hold on and add on as long as the function is enabled. A keyboard legato, if you enable it with a chord held and then you still have it enabled and you press another note, the first chord that you had sustaining would cancel and the next new note that you added would become the sustained note. And there again it just asks for a keyboard. Function type number 9 is a transposer. There are 3 types of transposers in this system. If you bring the cursor down to the transposer type and go through the list. There is an absolute, which is a return. Generally, it's a transposer with a value of 0, which will return you to standard 8-foot unison pitch. There is a relative transposer. Depending on the transposer value, will take you a half step. If it was a value of +1, would increment you 1/2 step every time the button for the transposer was pushed. Or you could put in a +2, which would skip and make a full step transposer, or you could put any number in here you wanted. Each time you activated this particular transposer, it would transpose to the transpose value that was entered. So generally, a +1 or a half step is usually what is used for a 3-button type transposer. In this case, you would have 3 definitions of a type 9 function. One as a +1 for incrementing 1/2 step up. The other would be a -1, which would take you 1/2 step down. And the third type would be an absolute transposer with a value of 0, and that would return you to 8-foot unison pitch. So 3 buttons to do a 3-button transposer, each one having them defined as a type 9 transposer, but the transposer type and the transposer value would be different. Function type 10 is a melody coupler, which is obsolete. There are a few obsolete functions in the system, and these have to be there because to maintain the integrity of the function list for the very earliest system. And so some of these, the melody coupler is now a function of function type 1. Or if we go up here to function type 1, division coupler, if we come down here and make that a solo to great at 8-foot pitch, and we come down and we activate the melody coupler and make it yes, then we have melody coupler types, and that's top note melody auto on, auto off, bottom note melody auto on, and bottom note melody auto off. And we just realized a few days ago that the auto off melody coupler is broken. So the only, if you want to experiment now with your melody couplers, the only type you are able to use is the top note and bottom note melody auto on. And what that means is that if you have a top note melody, let's say you're playing a 5-finger chord on the great, which is the couple 2 keyboard, what it's going to do, it's going to bring that top note, the 5th note that you're holding, it's going to couple only that note from the solo and play it on the great. And if you were to lift your 5th finger, and so you only had a 4-finger chord, then the auto on follower feature would make the 4th note the automatic top note. So it would automatically then couple down the 4th note rather than the 5th note. So that's why this melody coupler is now obsolete. Function type 11 is pretty much obsolete too. In fact, I don't even think it works anymore. This is a resultant coupler. Resultant coupler is also accommodated in function type 1. Division coupler, and that would be from solo to great, and or actually great to pedal, and then you would specify a pitch 10 2/3, and then you would have a bottom note limit. This is where the bottom note limits would come in. G0 of the 16-foot octave. through F sharp 1, which would be a 12-note couple. And so when you played this with a as a resultant, then you would have a I beg your pardon, that is not correct. It is a function type 3 normal rank output that has the top and bottom notes. So you would have the pedal being the keyboard. The rank would be a flute, and pitch offset would be 10 2/3, and then your bottom note limit would be G0, and your top note limit would be F sharp 1. And I'm doing this by using the plus and minus keys of the keypad. So now when you played this, if you had this particular function combined with a standard 16 and a 32-foot pitch, this would provide the 10 2/3 resultant notes for only a 12-note range. So where were we? Resultant coupler, yeah. So it's best to use, because you don't have in the resultant coupler, you don't have the note offsets that you can automatically enter in. It just makes a 12-note coupler, and like I say, I think it's been disabled. Function type 12 is what is called a function multiplier. If you need to turn on more than one function in a stop, then you would use a function multiplier and add the functions that you wish to turn on inside of it. So you are able to turn on 1, 2, 3, 4, 5, 6, 7, 8 functions through one stop. If you set the stop up like we did in the first tutorial of making our one-rank organ, by adding a function multiplier in the function output of the stop, and then adding more than and needing more than one function to be activated, you would put that function list inside the function type 12 function multiplier. Pizzicato modifier allows for pizzicato timing when you play. It puts itself between the keyboard and the rank or the coupler that you're activating and modifies its timing. Now this requires the definition of a pizzicato timing block, and so it's asking for the modified function, which is the function that you're going to have, which is either a coupler or a normal rank output, and the pizzicato timing, which is the pizzicato timing block that is defined in the system. So to go through that, let's say that we wanted to have, and I think we're going to have to create another function. So let's go to our function list. We have one function defined. So let's add one more, function 2. We will make that a type 3, which is the great keyboard, and the rank will be flute at 8-foot pitch. Now we go to PIZ, pizzicato. There is none defined, so we add 1. Go to pizzicato 1. This is where the timing block is defined, and we'll call this flute pizzicato for lack of a better name. And we'll come down here and we're going to say that we want the low 12 notes to sound for 80 milliseconds. So we type 80 and then the parenthesis, the number of notes we want to specify at 80 milliseconds. Then we come over to octave 1 and we type 70. And we want to do that for 36 notes. We want to make it a little bit faster. The slower note, we give it a little more time to activate the 16-foot. and then we want to speed the action up so the notes gradually get faster and faster so that they just burst on and then turn off. And then we'll bring this to 60 milliseconds for 25 notes. And that'll take us up to the top of the 4-foot pitch. So now we have the pizzicato timing block defined. We can go back to function 1, which is where we started. We can say function 2, which is an 8-foot solo flute, and we want to give it pizzicato timing block 1. So in some of the cases you have to build some new timing blocks, some new functions in order to carry out the function type you want to try, but you can do this with any particular stop. On your organ definition, you can add a pizzicato modifier, take any existing function that plays, and then just build a function type 13, put the stop that you want to modify, and then the pizzicato timing, and then apply that to a new stop, and turn them both on, turn both functions on, function 2 and the pizzicato modifier, and you will have a pizzicato relay. If we come up to function type 14 is a reiterate modifier. It's very similar to the pizzicato, except instead of just bursting on and bursting off the note, it reiterates it according to a rate and duty cycle that you specify in a reiterate timing block. Once again, we have to create by going to RIT, reiterate. We have to add 1. Go to RIT1. Call this a flute reiterate. Random timing, we want to put that to yes, because that gives it a little bit of error, random timing in it. Then we come down here, and generally you're going to reiterate in the 8-foot range, so we want to specify a reiteration time and duty cycle. So if we do this in milliseconds, and everything in these timing boxes are done in milliseconds, so if we give this a timing of 100 milliseconds on, and then a point, and then the duty cycle from 0 to 9, which is a 1 to 9, which is a 1 to 9 duty cycle ratio, and give it a 5, which is in the middle, which means that the note is going to be off for the same amount of time as it's going to be on at a 50% duty cycle. And then we give a left parenthesis, and we go 61 notes, and enter. Now we have a timing block of 100.5, 100 milliseconds on at a 50% duty rate side, 50% duty cycle. And now if we go back to function 1, and we call up the modified function, which is again flute, our solo flute, and we put the reiterate timing, which is flute reiterate, then it will reiterate. Now, there's an option. You can have up to 4 different pitches, and this is if you want to get kind of crazy with the reiterate, but generally if they're all left at 8, it's the most effective way of using it. You could specify a -12, an 8-foot, a +12, and a 24 pitch offset, so it would go 16, 8, 4, and 2, and every note is going to go 16, 8, 4, 2, 16, 8, 4, 2, but it's not very useful. So if we leave all of those at 8-foot pitch, it works out much better, but you have the option of doing whatever you want. We'll come back and show you how to build each one of these things so you can effectively know how to use it. Right now we're just going through the entire list. Function type 15 is a channel coupler, and I'm not going to go into this because it is very complex, and it has to do with setting up the crescendo and expression of the system. And like I say, it takes a little bit of time to explain, and our time at this point is better served going through the rest of the functions that are generally used. We will come back, and there will be an AVI that is has to do entirely with setting up channels, expression, crescendo, and everything else. So for now, we're going to skip over channel type 15 and channel type 16, which is a channel output, because that has to do with the same stuff. Function type 17 is a stop reverser. And what this is asking you for is a stop number 1. I don't think we have any stops defined in here, so I can't, let's look. STP, no. We'll add one. Call that an 8-foot flute. And if we specify stop number 1, then that will be an 8-foot flute. So if we have this assigned to a piston, and this is generally used in classical organs, then this will reverse the condition of this stop. If it's on and you push a piston that's set up to activate this function, it's going to turn it off. If you push that piston again, it's going to turn it on. It's just a reversible function of the position that stop was in. Now, a lot of people have tried to use this to activate and deactivate trems. It doesn't work because you may have one trem on and the rest of them off, and it's just going to reverse the conditions of those trems. And so your one off will be the only one on, and everything else will be off. So this is just primarily a control to reverse the condition, whatever it is. If it's on or it's off, it just reverses its condition. And you're able to specify up to 4 stops to be reversed from their positions. But like I say again, this just takes the condition it's in and reverses it. So it's not like a trems off and trems on reverser. We don't have such a function in the system. Keyboard sostenuto we kind of explained. This is in the legato sustain. This was a function type that was added a little bit later on. This is what is called the true piano sostenuto, and the information it requires is simply a keyboard. And when we go through the list, we'll come back and we'll demonstrate the legato, the sustain, the sostenuto. And what a keyboard sostenuto or piano type sostenuto does is it allows you to enable it. If you're holding a chord, it will sustain that chord as long as the function is enabled, but leave the rest of the keyboard open to be played normally, just like you find on a regular like grand piano sostenuto. Function type 19 is a MIDI program change. This asks you for a MIDI program number or MIDI channel number, and that would be 1 through 16 only. And then a MIDI program number, which would be 1 or 0, actually, would be 0 through 127. MIDI analog controller output. This is generally a MIDI function for driving volume. It asks for a MIDI channel, which will be 1 through 16 only. The MIDI controller number, which is usually 7 or 11, which is MIDI volume controller, and the minimum velocity that you want that condition to be set at. So if you want to use this to control the volume of a MIDI channel, you would need to specify a minimum velocity, which would usually be about 50. And that way it will not take the volume clear to 0. Because normally in a pipe organ, you never have a 0 volume condition. You always hear some noise. So this allows you to set a MIDI volume controller with a minimum velocity that it will go no lower than whatever number you specify in the minimum velocity line. A function type 21 is a MIDI fixed controller output. This is generally used for MIDI piano sustain, a fixed controller. If you don't know a lot about MIDI controllers, it would be best to buy a MIDI book that explains some of the things, because if you want to do a lot with MIDI, you have to understand MIDI, because there are a lot of MIDI functions in this system and they require you to have some basic understanding and knowledge of how to use some of the controller information, and it requires a lot of experimentation, and you know, you have to kind of know what you want it to do before you can make it do it. But in this case, a MIDI channel, again, 1 through 16 only. Okay, the MIDI controller number for piano sustain, I believe is, I'd have to look it up. Can't remember off the top of my head. It would be under the MIDI controller list. I think it's 60. I'm really not sure. Let me pause for a minute and look that up. Okay, a MIDI damper pedal or sustain is a controller number 64, and the minimum value would be 64 or 127, and that would be the controller value would be on, and that would send out a MIDI fixed controller for the damper. There's also several other fixed controllers, which would be portamento, sostenuto, soft pedal, and hold, etc. But there again, whatever the MIDI spec requires, we can accommodate, and whatever piece of equipment you're using, you can usually set that up to do all the things it demands, but you have to know your MIDI equipment in order to know what you want it to do. The next function type is MIDI set channel note velocity. And what this does is it asks you for the MIDI channel number, which can be 1 through 16 only, and then the minimum velocity that you want to set. In other words, if you want the unit to start at velocity 60 and the maximum velocity at 127, then when you enable this function, it will set a maximum velocity of 127 to whatever MIDI channel you specify. And then when you turn it off, the minimum velocity it will revert to is velocity 60, or whatever other number that you want to set that to. Activated piston is function type 23, and what this asks for is a piston number. And if we add one, give it a name, okay, and then go to function 1, and we put in the number general piston 1. What we can do is we can turn on a stop and also activate a combination action piston with the activation of this stop by having two functions in the stop, or just turning a stop on and it will automatically activate general piston 1. So you can force a piston to activate if you happen to need it for any particular purpose. This was originally set up for a role player function, but a few people have wanted to use it so that they could have a phantom piston that when they turned on certain combination of stops it would set the trems, and they did that through activate the piston. Function type 24 is a function delay. This again was originally set up for role player encoding, and it will delay the turn on and turn off, whatever you specify, or both, of a particular function. And there's no real practical example to show you here, but you would type in the function number, which would be function number 2, and then you could give this a 2000 millisecond or 2-second on delay, so that if you were turning this on, then it could be whatever function you wanted it to be by just specifying in the function line what function you wanted it to be. If you wanted that to be a trap function, a cymbal strike, or a bass drum strike that you wanted to have come on 2 seconds after you turned on a particular stop, this would allow you to do it. Function 25 is a very useful command, and this allows you to activate a typed character string. And what its most practical use is for loading combination action memories from buttons. If you put the command in cload C1, C for combination, load for combination load, and then the file number C1 as the function name, when you activated this particular function from a button or a switch, it would be just like you typed in cload C1 from the command line and press the enter key. And so you can use that to load combination files, you can use that to start recordings, you can use that to finish recordings. Whatever you type in here that is a valid system command, R for example, will start a recording. F will finish a recording. Kill will kill the playback list. Whatever you want to put in this command and tie to a button, this is the command to use. It allows you to do a lot of very interesting things from the standpoint of activating buttons and switches that actually would be the same thing as an operator typing in commands from the keyboard. A signal toggle is function type 26, and what this does is this will toggle a function on and off. In many cases of it in advanced programming where you're working with complex switching algorithms, you need to toggle a function on and leave it on in one state and have it left on when the conditions of the switches meet another state. And once again, there's no real specific example where this is used from. It's just an available function. Again, it was put in here for role player type conversions and operation. But you're more than you can play with it if you want. Function type 27 is a MIDI stop controller output. This was set up for activating the Allborn Galante sound modules. And what it was designed to do was to turn on and off stops that were on the Allborn Galante module. And the MIDI channel number is the channel number, and I think it was usually channel 8, that used for data communication between MIDI and the module. And then it asked for stop on controller and stop off controller, and then the stop number from 0 to 127. And I'd have to go back and look in my notes what the stop controller was for this. I think it was 98 and 99 were the controllers. These were non-registered controllers that Galante used. And then the stop number from 0 to 127. So 0 was pedal stop number 1, and I think that had 4 stops in it. So 0 through 3 would turn on the 4 pedal stops, and then 4 through whatever would turn on the lower manual, and then so on and so forth for the upper manual. So this was a convenient way of plugging a Allborn Galante unit into our system and being able to control the stops from the directly from stop keys. So you would take this type of function and attach it directly to a stop, and when you turn that stop on, it would send out this combination of MIDI controls to the Alborn-Galanti box, which would change the stops of that box. Function type 28 is a piston sequencer, and this is basically set up like the 3-button transposer. You have a sequence value of +1 or -1 or 0. 0 would be the start. As you can see up here, when it shows a value of 0, that is piston sequencer start. When you put down here, that means that's the decrement number, which would take the sequencer piston from any positive number back down to 0. And if you had +1, this would increment the piston sequencer from 0 condition or nothing turned on to whatever the last highest set piston sequence was in the definition or in the combination action file. So it's a very simple thing. You would need 3 of these function type 28s, as I mentioned, 1 for a plus, 1 for a minus, and 1 for a 0, and that would be all you would need to do to initiate a piston sequencer on your system. And then once you got that installed, those 3 buttons on functions, then you would go to the system operation manual and read the information there about setting up and using the piston sequencer. Function type 29 is a manual reverse. This is used primarily for classical French literature, where the great and the choir manual were reversed. So this allows you to specify a keyboard number 1 and a keyboard number 2. In this case, we only have 2 keyboards defined, so I guess we could go to keyboards and add 1, keyboard 4, come down here and make that choir, go back to function 1. Okay, so now the great and the choir would be the keyboards to reverse. So when you activated this particular stop, it would take the keyboards and physically reverse them so that notes that played normally on the choir would now play on the great, and notes that played on the great would now normally play on the choir. This can be used also in the theater organs to move second touch contacts to first touch and first touch contacts to second touch. So you can do this, use this particular function for some very interesting effects. If you need, for example, to have just a few stops on your accompaniment manual and a great number of stops on your second touch, then you can use this particular function to momentarily reverse the key contacts of your manuals and give you a great variety of stops on second touch that normally you wouldn't have, and a less variety of stops on first touch that you normally wouldn't have. So you're welcome to experiment with this function as well. Now this function by itself does not, if you're using it in the classical sense, does not also transfer the pistons. Those must be done through some rather complex programming to actually change place, have the pistons change place with each other, and we're not going to explain that at this point, but eventually there will be another AVI produced for that. But on the most part, we program this for the customer, for the classical customer who needs that particular functionality, and once it's programmed, it's usually never changed. Function type 30 is a signal inverter, and this again was set up for a role player operation and has no real practical purpose in the pipe organ. Generally speaking, it would allow us to turn on a function or invert the operation or invert the status of an output function. And like I said, there's no real significant use in standard pipe organ use. Function type 31 is a signal pulsar. This was also used for role player operation. It has an output function that you can specify a minimum on time and a maximum on time and a trigger on signal off. This can be used in a pipe organ. You're welcome to experiment with it, and you can use it for whatever you think you'd want to experiment with. But all you have to do is fill in these functions, give it a valid function number, a minimum on time, and that's in milliseconds. So you would have, if you wanted to have it on for a second, then you would put in 1,000 milliseconds. Well, that's 10 seconds. 1,000 milliseconds. That's a second. Would be the minimum on time, and you could have this trigger on signal off. So like I said, there's no practical application in pipe organ, but you're welcome to play. Function type 32 is raw MIDI record. And raw MIDI record is used now for solenoid pianos. These are the piano disc type or QRS Pianimation electronic solenoid operated pianos. And it allows you to record the raw MIDI information, velocity primarily, coming from the record strips of these pianos in parallel with the organ recording data from the console, and then play that back with full velocity back to the MIDI piano. So if you want to set up a piano that has a velocity sensing strip and you want to record that information for pipe organ piano duets, you would set it up using the raw MIDI data record. And what you have to do is set up a special stop that is not tied in with the combination action of the organ, so that this stop can be turned on. And what it does is it asks you for the channel number of the piano, which in most cases on these solenoid pianos is channel 1. And what that does is when this is active, then it does not allow information to be echoed back through MIDI. So that if you're recording that information from a piano keyboard and sending it to the computer, it's not echoing it back out and playing the solenoids at the same time. So you have to specify the MIDI channel number, and that deactivates that MIDI channel number from the console. And it also, if you had piano stop keys set up to play channel 1 out MIDI without velocity from the organ console, it would disable those when the system was recording. Function type 33 is a Proteus sound module bank program selector. This is for the older Proteus, non-Proteus 2000 devices. It asks for a MIDI channel number, a MIDI bank number, and a MIDI program number. This allowed you to get beyond 127 program change or 128 program changes on a Proteus unit, which sometimes had 500 and 600, 700 different sounds contained in them. You could use this to force a bank and a program change number on a specific MIDI channel. MIDI program change toggle. This was set up for the Johannes electronic organs, and they had a situation where they would give you a channel like channel 8, and then a MIDI program number of 44, and when you turned the stop on, it would send out MIDI channel 8 program number 44 on, and when you turned the stop off, it would send out again MIDI program channel 8 and MIDI program change number 44 to turn that particular stop off. So this is how the Johannes organs that were tied to our system were controlled. MIDI function type 35 is for exporting information from the Uniflex system to control an Allen organ. Allen organ requires a division channel number and a master stop list number, and by specifying the channel 4 and master stop list number 355, when you turn the stop on, it would send out all the non-registered parameters and bank changes and information that would turn on whatever the master stop list number 355 happened to be. And you could use this for playing back a sequence using an Allen organ. Function type 36 grew out of the need for being able to control primarily the Proteus 2000 units and essentially just about every other thing that didn't fit into a particular category in MIDI. This is a generic controller, very powerful, and it allows you to have up to 5 different actions from one stop control. It has stop on and off action. You can fill in the blank here, active only if the stop is on, active only if the stop is off, active only when the active for stop on and stop off. And then it asks you for the MIDI channel, which would be 1 through 16 only. The active event number 1, you could have that turned on if it needed to be a controller and a value. If it only needed one controller value, then that would be set to yes. Then the event controller would be number whatever the parameter of the unit called for, 66 let's say, and the event value here would be 127. If it did not require the same type of controller and value for event number 2, you would leave that set to no. If you had the event number 3, which required a controller number and then a stop on and stop off value, you would enter those 3 here. And if it required then an additional active event number 4, which was a program stop on and a program stop off, then you could specify those numbers here. So by the combination of any of these 5 different categories, you can control quite a bit of MIDI general equipment depending on the specific needs of that equipment. And we're finding that more and more MIDI devices are becoming more and more complex to control. So we came up with this generic type stop control to handle most of those. Function type 37 is a MIDI registered parameter, and there's no real specific application I can demonstrate for you because some things need MIDI channel registered parameter numbers, other things don't, but it's here if you need it. Function type 38 is non-registered parameter information, and you can use this kind of stuff if you need to build a custom type of controller that isn't in with any of the other type of MIDI information we have by using what's available plus a registered parameter or a non-registered parameter. Those type of things in conjunction with each other can be made to do custom MIDI controls. Function type 39 is a simulated input signal, and this allows you to put in an input address and simulate it from the activation of a stop. So if you wanted to simulate input address, because there was really no way to force an input address on like we could force an output address in the system. If you needed to force ABI1 as the input address, and you needed to have that turned on when you turned on another stop or whatever, then you can use this function to do that. And you can have the option of a pulse signal, yes and no, so that if it was just a momentary pulse, it would activate it. If it was a sustained signal, then you would use pulse signal no, but if it was only going to be a pulse signal, then you would change the parameter to yes. And then you could simulate turning on an input signal. Number 40 is a group clear. This has to do with group latch, which are essentially radio buttons. And we're going to cover those in a separate operation, AVI, which explains how you can set up radio buttons now to have lighted selectable buttons. And this is primarily, again, for MIDI, where you have a program change button that is illuminated. When you send out the program change for harp, it will activate that button. If you have another button in the group that is for strings and you push that, then like a true radio button, the first light will extinguish and the next light will illuminate to let you know that this is the active program change that has been sent. So we'll go into a separate complete explanation of how these two elements, group latch and group clear, affect each other. Function 42 is a MIDI real-time start message. This is primarily used for rhythm boxes. Anything that needs to have a real-time start message followed by a real-time continue message and followed by a real-time stop message sent out when you activate a button. And this is primarily, as I said, for rhythm units. Some of the fancier Dr. Rhythm and Roland units require that if you want them to start and use the computer's synchronization to synchronize rhythm units with the Uniflex system, so that when you make a recording that everything is in synchronization, then you would use these real-time start, stop, and continue messages. And that brings to an end all of the different function types of the system, ending with function type 44. Now we'll go into another AVI presentation that will go into specific examples of the most common used functions in the system.